Welcome back to Elias Academy, day 45. Today we're going to be practicing some similarity proofs that we've kind of were introduced to in the past 2 days. So we're going to practice particularly side similarity and side angle side similarity today. Let's take a look at this first one. So here they give us the similarity statement. We're always going to end our proof with that statement. And it's useful to kind of like go through the problem and see what information you're given and how you're going to use that information. So right off the bat, I can see I have 1, 2, and 3 sides. So this is definitely going to be a side similarity proof. And I'm just going to identify corresponding parts. So to do that, I look at like triangle 1 and I ID the smallest side. That would be the number with the least value, the smallest value. So 16 is the smallest. I look at the corresponding triangle. I'm going to call it Roman numeral 2. I say, out of these numbers, which is the smallest? And 4 would be the smallest. So my technique is just circle the small and then look for the bigs now. Out of 36 and 28, 36 is the biggest. So I'm going to box off the biggest. And then here, 9 is bigger than 7. That's how I know those sides correspond. And I'm just going to leave blank that third side because that third side's the median, and these will correspond to each other. In the margin, I'm going to show my work. I recommend you do that. Just so when you write up the proof, you know everything checks out. 16 over 4, that will be a ratio. 28, change that color. 28, right, this thing over the corresponding side, 7, that will be a ratio. And then last but not least, the big one. So like that one there, 36 over 9. And you know, I have my calculator, so I'm just going to use that, do all this work. I like to get everything in front of me, and I'll just start typing it in. So 16 over 4. Hey, apparently that's 4. 28 over 7, 4, and I can predict 36 and 9. It's going to give me 4. So all of these things have a ratio of 4, meaning that scale factor. This is really like a dilation of 4. Each side's getting multiplied by 4. So here are my 3 sides, and now I'm ready to write my proof. The way I'm writing this proof is going to look a little bit different than how I introduced it in class. If you want to talk about it, come see me, but this is kind of how we're going to start writing proofs from here on out. We're going to skip that first part where I forced you to write the diagram with info and given. We're comfortable enough with proofs that we know where to start. So first thing we're going to start with is these ratios. So I'll do side QP. Right, that's that 16 divided by side TS. That's going to equal 16 over 4, and that equals 4. My reason for writing that is the ratio of corresponding sides. And I'm going to go to 2. And that's going to be my next ratio, which was PR, boom, boom, over SU. And that was 28 over 7, which is 4. And that's the same reason, the ratio of corresponding sides. That's why we're writing it, why we're allowed to write that. And then my third fact, each of these are side facts, by the way. My third fact is Q to R over T to U. And that would be 36 over 9, which is, as we already saw, 4. And my reason is the same. It's the ratio of corresponding sides. And that's my final side. So once I see I've got my three sides, I'm allowed to wrap up this proof. I'm allowed to say literally that thing. You would just copy it over. So triangle PQR is similar to triangle STU. How did I know that? Well, that's the side, side, side similarity postulate. I'm lazy. I don't feel like writing out similarity, so you're good to go. I'll see you in the next one.